we are following important questions. Today's important question starts with CLASS12 reaction. You know what it is, CLASS12 reaction? Which do not having alpha hydrazine. Two molecules of which do not having alpha hydrazine combined with in the presence of concentrated alkali, that means sodium hydroxide or potassium hydroxide, while heating, you will get related salt as well as alcohol. That is only. Now, which do not have alpha hydrazine? Is I will write it HCHO. As I am writing only, you will come to know this is a formaldehyde. HCHO. Okay. Now this combined with that in the presence of strong alkali KOH or potassium hydroxide, any one you can take. So what you will get it HCOOK plus CH3OH. Okay, this is a simple reaction. Now what do you mean by alpha hydrazine? Yes, I would like to explain here. CH3 C double bond OH. So this is aldehyde. Now the same way another one CH3 C double bond O CH3. This is a keto group. Okay. Now another one CH3 C double bond O OC2H5. So this is a ester group. So these are all having what it is, carbonyl carbon. So carbonyl carbon means which is having the special character, that is having what it is, electron withdrawing group. This is having what it is, electron withdrawing group. So the electron withdrawing group which is connected with that carbon is called what it is, alpha carbon. What it is? What do you call? Alpha carbon. Actually, this is a functional group. Yes, CHO, it's a functional group of aldehyde. CO, it's a functional group of ketone. COO, it's a functional group of ester. You know very well. Now, in this carbonyl group, which is attached with that hydrazine, that is called what it is? Alpha hydrazine. Alpha hydrazine. Okay, now this alpha hydrazine is having what it is, a special character which is called acidic in nature. So this acidic in nature, what it will do, you know, this aldehyde combined with another aldehyde to form what it is, condensation reaction takes place and you will get the product aldol. That means aldehyde also you will get it, alcohol also you will get that formation. That compound is having aldehyde group as well as alcohol group, it will be there. So that is called aldol condensation. Now why should I mention here means this alpha hydrazine I wanted to mention. Now in this point, do you think it is having that alpha hydrazine? Alpha carbon is there only, in that it will attach with that alpha hydrazine. That is not, this is a functional group. CHO, it's a functional group that is attached with that, does not have that what it is, alpha hydrazine. That is what CLASS12 reaction mentioned, which do not have that alpha hydrazine. So two molecules of which do not have that alpha hydrazine combined, and while heating you will get that related salt. That means formaldehyde form potassium formate and methyl alcohol. Okay, now this is a aliphatic. Shall we go for the aromatic? Do you think which is having that what it is, which does not have that alpha hydrazine in that aromatic compound? Benzaldehyde only. What it is? Benzaldehyde, CHO. Here also it does not have what it is. CHO, it's a functional group. It does not have alpha carbon, neither alpha hydrazine. So the same way another molecule of CHO. So you will get in the presence of KOH, strong KOH while heating. What you will get? You will get that same related salt. You will get what it is, COOK, sodium benzoyl plus benzyl alcohol. What is benzyl alcohol? CH2OH. Yes, you got it. Now this is called CLASS12 reaction. Aldol reaction which is having alpha hydrazine, which does not have alpha hydrazine, that is called CLASS12 reaction. Hope you're clear with this CLASS12 reaction. The next one more question. Convert benzoic acid to benzyl alcohol. It's so simple and you will get two reactions. Okay. Now the first one, this is benzoic acid. Okay. COOH connected with Benzene. Yes, benzoic acid in the presence of oxidizing agent KMNO for anything oxidizing agent you can take and dilute H2SO4. Okay, dilution. You will get what it is benzaldehyde. Benzaldehyde CHO. Yes, benzaldehyde. Now you have to get what it is benzyl alcohol. So benzaldehyde, this is the first reaction. Or second reaction takes place. Benzaldehyde CHO and it reacts with the HCHO. Okay, what is this HCHO? In the presence of sodium hydroxide, strong sodium hydroxide. If you heat, what you will get it? HCOONE plus benzyl alcohol. Yes, CH2 OH. This is benzyl alcohol. We want benzyl alcohol only. No, yes, we got it. Now, this is actually formaldehyde. Already I mentioned which does not have that what it is. Alpha hydrazone. See, this is a functional group. It does not have any carbon of alpha carbon. And that is connected with hydrazone only alpha hydrazone. This is only hydrazone but not alpha hydrazone. You please remember. So this is benzaldehyde, this is formaldehyde. This is aromatic and this is aliphatic. Both are different, but aldehyde it's common. Now this is called cross-cannizzaro reaction. Cross-cannizzaro reaction. Okay, so they may give that explain about the cross-cannizzaro reaction. You may get the direct question or you may get convert benzoic acid into benzyl alcohol like that also you may get it. Hope you're clear with that what is alpha hydrazine which do not having that alpha hydrazine. What it is cross-cannizzaro reaction. From one question we can get many answers. Okay, hope you're clear with that. The next question, it's very simple. Acetone converted into acetoxide. Okay, now acetone, what is the formula? CH3, C double bond O, CH3. Right? Okay, combined with NH2OH, hydroxyl amine. Okay, now hydroxyl amine, how to remember that? So here NH3, one hydrogen, I just remove that. Removal of hydrogen, replacing of OH. So this is what it is, hydroxyl group. Hydroxyl group attached with amino group. So we can say hydroxyl amine, OH. So we can say what it is, hydroxyl amine. Easy to remember. Okay, so hydroxylamine combined with acetone, condensation reaction takes place. So what is it? Condensation reaction? It releases the water. Okay, one small rearrangement. I just put it like this way. So here, what it is? NH2OH. Now what happened? The water molecule releases. So what you will get that answer? It's so simple. You just remove that water molecule. So CH3, CH3, double bond, NOH. Oxime. This is called what it is? Oxime. Acetone group, CH3, CH3, double bond O. That removal of O only, oxime it is. So what do we call here? Acetone oxime. Right? Got it? It's so simple. The next one more simple question. 2-propanone converted into tertiary alcohol. And it's very simple and Corona time they asked this question. Okay, and come to this point here. Propanone, it is nothing. CH3, C double bond O, CH3. 3 carbon, it is prop and on propanone combined with the methyl magnesium bromide Grignard reagent CH3 MgBr. Okay, so you will get it. You will get what it is, CH3. See the bond breaks. So here O MgBr and here CH3 and here what it is, same CH3. Okay, again acid hydrolysis HOH, acid hydrolysis, no, H plus. So what happened here? CH3 See here OH will be there. OH it will go and join over here and CH3 and again here one more CH3. Yes, you got, and then Mg, here Br, and here what it is? OH. Okay, already we have seen in that our last chapter only. That's what I mentioned. Organic chemistry, it's a interrelated. They may ask that question there as well as here. Sometimes this questions, aldehyde questions, they may ask in haloalkane, haloarene also they may ask. Okay, hope you understand how to convert the 2-propanone converted into tertiary butyl alcohol also, we can say tertiary alcohol also we can say. Hope you understand. Now next to one more interesting question, Friedel-crafts reaction, and it's very important. So benzene reacts with acetyl chloride CH3 C double bond O Cl. This is acid chloride also in the presence of AlCl3. AlCl3 acts as a Lewis acid. Already I mentioned. Okay, now what is the product you will get it? You will get it acetophenone C double bond O CH3. So this is called acetophenone. Okay, so this is what it is, benzene. Benzene, this is acetyl chloride. Acetyl chloride. Simple it is. Okay, now next one here, of course, this is acylation also we can say, acetylation also we can say. Acetyl chloride, acid chloride. Okay, now one more thing, benzene reacts with acetic anhydride CH3CO, the same CH3 CO, both connected O. So this is called acetic anhydride. Anhydride. Okay, now this also in the presence of AlCl3. Okay, now what you will get it? The same acetophenone only you will get it. The major product only they are asking. Okay, C double bond O. Here what it is? CH3. Okay, so acetophenone. So you are thorough. Suppose if they mention C6H5, if they mention means what it is? C6H5. So what do we call this one? This one we call what it is? Benzoyl chloride, right? Benzoyl chloride. Okay, so this is benzoyl chloride C6H5COCl. Okay, the same. Now what is the product you are thinking? The same. Instead of CH3 you just put it C6H5. Instead of acetophenone you will write benzophenone. Benzophenone. That's all. Hope you're clear with it. Okay, now these three reaction also comes under what it is? Friedel-crafts reaction, and it's very, very important. Acetyl chloride acylation question. They may, if they ask acylation question also, that is related to Friedel-crafts reaction only. So Friedel-crafts reaction, what are the component? Benzene with acetyl chloride, benzene with benzoyl chloride, benzene with acetic anhydride. So these are the main component, and you are getting the product what it is? Acetophenone, benzophenone. Hope you're clear with this. The next one more interesting and important naming reaction, Clemmensen's reduction reaction. Okay, generally they may give directly Clemmensen's reduction. Reduction means hydrazone, it's a mandatory. And sometimes they may not give the Clemmensen's reaction only they will ask. Okay, now it's very important question. Yes, now aldehydes are ketones reduced in the presence of zinc amalgam in concentrated HCl. You are getting alkane is the product. Okay, now I just mentioned here CH3, CH2, CHO. Okay, now this is a aldehyde. Okay, and reacts with hydrazone in the presence of zinc amalgam certain Hg, and this is actually amalgam. Amalgam. Okay, and in concentrated HCl you will get what it is? Alkane, the same number of alkane, CH3, CH2, and CH3. Okay, so you will get alkane as the product. How many carbons are there? That many. What it is? Carbon available. That is actually alkane. What it is? This is propane, right? Propane. And this is what it is? Propanaldehyde. Propanaldehyde. Okay, now aldehyde. Okay, now ketone also. Now, for example, ketone CH3, C double bond O, CH3. The same hydrazone. See, reduction means hydrazone, it's a mandatory. The same thing. Zinc amalgam, ZnHg. Zinc amalgam in the presence of concentrated HCl. You will get what it is? CH3, C CH3, CH2, CH3. The same propane, and this is propanone. We can say acetone also. Acetone, it's a common name. Propanone. Okay. Hope you're clear with that. Aldehyde or ketone reduced in the presence of zinc amalgam in concentrated HCl. You will get alkane. What it is? Alkane. Okay, they may ask the question, how to convert aldehyde into alkane? That way also they may ask. Indirect question, how to convert aldehyde or ketone into alkane? That is a Clemmensen's reduction test. Hope you're clear with this. The next one more important question. All the naming reactions are important in one among Wolff-kishner reaction. Okay, and it's very important also. Yes, let us go for that. Now, what is that Wolff-kishner reaction? Aldehydes are ketone combined with the hydrazine and followed by strong alkali along with ethylene glycol. You will get that alkane. Alkane is the product. Okay, now come on, let us go for the point. CH3 CH double bond O, aldehyde combined with the hydrazine H2N NH2. Okay, this is called hydrazine. Okay, now already I mentioned no hydroxylamine, the same way one hydrogen which is replaced by NH2 amino group. Okay, now you are getting now anyway that reduction reaction. This also reduction reaction only. Wolff-kishner reaction also reduction reaction. Hydrazine ammonia compounds comes means that is also one way we can say it's a reduction reaction. Yes. Okay, now what is the product you are getting? CH3 CH double bond N NH2. A simple way for you to remember. I'm bringing all these important questions for you. Okay, now this is reacts with what it is? Strong NaOH. NaOH or KOH along with ethylene glycol CH2OH. Here CH2OH. Okay, see dihydric alcohol already you have learnt in alcoholic chapter. No, this is ethylene glycol. Ethylene glycol. Okay, so what is the product you are getting? You are CH3 so you will get what it is, the same number of carbon, alkane only you will get it. So what is the name? Ethane. Okay, hope you're clear with it. Aldehyde, this is what it is. CH3 CHO, it's acetaldehyde. Ethanaldehyde. Okay, acetaldehyde. This is common name acetaldehyde. Ethanaldehyde also you can say. Ethanaldehyde or acetaldehyde converted into ethane by Wolff-kishner reaction. Okay, so here hydrazine and the followed by this reaction and followed by you are getting alkane. Now the same way I just put it acetone also. The same thing only. Acetone. What it is acetone? CH3 C double bond O CH3, I just put it double bond over here for that to relieve water. CH3. This is what it is, acetone or propanone. Okay, what do we call? Propanone. The same hydrazine, okay, water molecule releases. So what is the product you will get it? Instead of hydrazine, you will get CH3. Okay, the same thing here also. Now this three carbons are there, but there it is two carbon for acetaldehyde. Okay, now what it is here? One CH2, CH3. So what do we call this is propane. Propane. So that's all. Aldehyde or ketone reacts with the hydrazine, reduced with the hydrazine, and you are giving that product that is followed by that sodium hydroxide, strong alkali, KOH or NaOH, along with ethylene glycol. You are getting alkane. Alkane. Okay, that is a hydrocarbon product. You will get it. So indirect questions also they may ask how to convert aldehyde or ketone into alkane. Wolff-kishner reaction is one more reaction. Wolff-kishner reaction. What are the compound? Aldehyde or ketone with the what it is hydrazine, along with that followed by what it is sodium hydroxide and ethylene glycol. Hope you're clear with this. Next, one more simple and interesting question. This is cyclobutanone, keto group, cyclobutanone combined with the HCN. What is the product that, and it is very important also. Yes, cyclobutanone. This is cyclobutanone. Okay, keto group combined with the HCN. You are getting what it is. That is a cyanohydrin of cyclobutanone. That's all. Cyanohydrin. Okay, one side OH, the other side is CN. So, cyanohydrin of what it is? Cyclobutanone. Cyclobutanone. Okay. See, actually, generally, this aldehydes and ketones, carboxylic acid, there are number of important questions. Are this chapter only important questions will be what it is occupied. Okay, hope you understand all this, and you have to go through thoroughly all the important questions. Actually, 2020 all easy questions they have asked because of that corona. Now we cannot expect in that way. Indirect questions only they will give. Okay, hope you understand this point. Next, one more simple questions, and it is important. CH3CO, CH2COO, C2H5, ethyl acetoacetate. Okay, combined with the sodium borohydrate, 100%. It's a reduction reaction. Okay, now what is the product? Yeah, after that, what it does acidification, water hydrolysis if it takes. So what happened? It is reduced with the keto group. Here also see double bond O will be there. So only one what it is CO group will affect. That means what is the product you will get? They are asking only the product. Okay, CH3, C here OH, here CH2, COO, C2H5. Okay, so this is the product. Okay, so suppose again if it reduces, then you will get diol formation. That means two hydroxyl group will be attached over here. Also you will get that in that way. Okay, if suppose if it reduces with lithium aluminum hydride, you will get that diol formation. Okay, hope this is fine. Now next one, this is salicylaldehyde. Salicylaldehyde reacts with sodium cyanide along with HCl, cyanohydrin only you will get that product. Okay, cyanohydrin means where it will go and affect aldehyde compound only you will get that changes. Okay, so you remember in that way. Here COOH, it will be safe remaining there only. Here C, here OH, and here CN. So this is, so that means benzoic acid cyanohydrin. Like that you will get the product. And Clemmensen's reduction reaction. Clemmensen's reduction, it is very simple. In our last video, we have discussed diisobutyl aluminium hydride. This is for that, used for reduce that cyanide group into aldehyde. Okay, I just mentioned CH3, CH, double bond CH, CH2, C triple bond N. Okay, now this is the component. Okay, reacts with the hydrogen and in the presence of diisobutyl aluminium hydride. This is the reduction process, Clemmensen's reaction. Okay, now I just mentioned here, and these are all very important. Okay, I just rub this. So what is the product you will get it? Okay, now 3 CH double bond CH CH2 CHO. So you will get this compound. It does not affect that non-polar molecules of C double bond C. It will affect only that C triple bond N. This is polar molecules. It will affect partially. It will affect that. So that is what it is. Diisobutyl aluminium hydride. Hope you're clear with this. This is very interesting and important question. HVZ reaction, Hell-volhard-zelinsky reaction. Okay, now in this reaction, aliphatic acids or aromatic acids reacts with the halogen, chlorine or bromine combined with in the presence of red phosphorus. You will get alpha halo acids. That's all. Okay, now for example, R CH2 COOH, aliphatic CH2COOH combined with X2 halogen, that is chlorine or bromine. Okay, in the presence of red phosphorus. Okay, so what you will get it here? CH3 only. So R, I just mentioned general formula no R, CH, here Cl or X only. X we will put it. COOH. Okay, for this reaction, one important requirement is necessary. What is it? It has to get that alpha hydrazone. So what do you mean by alpha hydrazone? Starting also I just mentioned what do you mean by alpha hydrazone. Where there is a functional group next to carbon, it is alpha carbon, and the next to hydrazone, it is alpha hydrazone. Hope you're clear. Okay, now this is having that alpha hydrazone, so that will give halo acids. You will get it. Now we'll go for that main CH3 CH2 COOH. Okay, now the next one Cl2. I just put it here. Red phosphorus. Red phosphorus. Okay, now what you will get it? Before I could write, you will answer for it. CH, yes, Cl, COOH. So the 2-chloro propionic acid. Propionic acid. Okay, now this is what it is, only propionic acid. 1, 2, 3, 3 carbon it is there. So we can say it is a propionic acid. Propionic acid. So the main thing, it has to get that alpha hydrazone. So then only what it is, this reaction will work out. So this is done by what it is, Hell-volhard-zelinsky reaction. Hope you're clear with this. This is very, very important. HVZ reaction for evergreen question. This is very important and interesting also. Cyclopentanone combined with hydroxylamine and the presence of acidification. What you will get it. Already we have gone through cyclobutanone also. Now cyclopentanone. You know how much they are giving that preference for this question. Please go through thoroughly. So cyclopentanone reduced, that it reduces that water. So you will get oxime product only. So just I'll put it that H2 like this way. H2. Okay, for water, removal of water. So removal of water will be taking place. So here, it's very simple. So you will get the same kind of that what it is, oxime product only. So here what happened, water removed, then automatically NOH. Okay, so NOH, it is oxime, pentanone oxime, cyclopentan, right? Okay, cyclopentoxime, oxime. Right? Okay. Now next one. This is cyclohexanone. Reacts with 2,4-dinitrophenylhydrazine. 2,4-dinitrophenyl phenylhydrazine. ZINE. Okay. Now phenylhydrazine. Okay. Hydrazine means NH2. NH2. This is what hydrazine. Now phenyl group is attached, so that phenyl hydrazine. So nitro group which is attached to 2, 4, what it is, phenyl hydrazine, like that you will get it. So this is the first one. Second, 3, 4. So this is 2 and 4. dinitrophenylhydrazine. Okay, now what is the product? And first and foremost, this is what it is, cyclohexanone. Cyclohexanone. Hexanone. Okay. Now, what is the product? The same thing only. Water molecules you will be removing. Then you will attach with that. Simple it is. Okay. So, you will get what it is. Double bond N. Here NH. Phenyl group which is attached. That is attached with what it is. Nitro group. That to what it is. This is NO2 and this is NO2. Okay, so 2, 4, what it is, dinitrophenyl hydrazone, only you will get it. Cyclohexanone 2,4 dinitrophenyl hydrazone, ZONE. That name will be coming. Cyclohexanone along with the 2,4 dinitrophenyl hydrazone. Like that you will get it. Hope you're clear with it. This is very, very important question. Hope you got it. Thanks for watching and for your great support. Thank you.